Welcome to the Building Information Modeling, BIM, for Reinforced Concrete conference call. My name is Eric and I'll be your operator for today's call. At this time, all participants are in a listen-only mode. Later, we will conduct a question and answer session. During the question and answer session, if you have a question, please press star, then 1 on your touch-tone phone. Please note that this conference is being recorded. I will now turn the call over to Michael Hernandez, Senior Project Manager at Parsons, with over 20 years of field experience in construction. Michael Hernandez, you may begin.
Thank you, Eric. Just to give you a little context about what I've been doing in my career and how I ended up being engaged is I spent the first few years working for a general contractor, M.A. Mortensen, in the late 90s, and then I spent the next 18 years working for Baker Concrete Construction in various and projects at the Denver Broncos Stadium, and then a series of projects in South Florida, at Miami International Airport, built a couple terminals, and then we built a 6,200-foot bridge from Miami International Airport to the Miami Intermodal Center, tying to another large bridge from there to an existing heavy rail system, design build in Fort Lauderdale Airport for second of its kind runway bridge. And then I oversaw the engineering and BIM department for Baker Concrete in South Florida for a couple years before trying to move my family back to Colorado. So I took a job based in Colorado building a bridge in Arkansas. So currently a general contractor overseeing a $100 million bridge as the senior project manager. Related to BIM, I've been interested in BIM since the early 90s, and through my work with the design build for the runway bridge and then overseeing the BIM department at Baker, you'll see the basically projects that I've directly worked on or managed a team that was working on those projects. And I'm not really selling anything, so I'm not a vendor of any software or anything. If you're seeing specific logos from different companies in the presentation, it's because I've worked with them and they provided me some general information. The goal here is to be educational, vendor neutral, but I mean, obviously this came from somewhere, so if you have specific questions about how we did that, I'd be happy to tell you. So anyway, just trying to share what I learned through working with teams and then working through ACI. I'm actually on the ACI 131 BIM committee as voting member, and also on the tolerance committee, laser scanning subcommittee, also on ACI 117, as well as the mass concrete committee and E703 concrete construction practice. So no further ado, let's get into the specifics. So those of you who don't work with BIM every day, VDC is virtual design and construction. The people that on a daily basis perform this work call themselves virtual design constructors. So that's a lot more specific to what actually happens than building information modeling is. So the analogy we're going to use today is a little concrete universe, and each subset of that has a different type of model that will be generated by potentially a completely different person on the team. So we're going to go through 3D and 4D, linking. We're going to go through 3D and 4D, linking the models to the schedule. A little discussion about 5D and basically how these work together. And if you're embracing this technology, different applications within the concrete construction world. Related to each of these, I'll try and give you some feedback on the level of difficulty of performing that type of work, either low, medium, or high difficulty, the effort or dollars associated with doing the work, and then what kind of reward to expect. So to get part of the punchline, the multi-billion-dollar contractors that are very BIM integrated will claim that they can get 5 to 7% cost reduction on the overall project cost. That's money dropping to the bottom line by using BIM and VDC in a serious manner. Now, to be conservative, we'll say a 5% cost reduction, and in order to do the work, you could cost as much as 1% of the project cost to perform the BIM. So 5% savings, 1% cost, you get a net of 4%. That's a realistic number for a contractor who's heavily engaged. So let's just talk about the concrete model. Let's say that you're either a general contractor or a concrete specialty contractor, and you want to do some BIM, but you aren't necessarily interacting with the whole team. We'll look at some things that could be done individually and some elements of the work that would require integration. So quantity takeoff, basically if you're in construction, you're doing a quantity takeoff on some level already. Now, in a complex shape, like the one you're seeing in this image, complex the elements, the better you're able to estimate and visualize what you're having to construct if you build it in 3D. So the difficulty of doing this specific thing is actually fairly low. Basically, you can build it from a BIM model. There's not a lot of effort, but the reward isn't real substantial. It'll help you specifically if it's a complex shape, but you're not going to get big savings out of this specific thing. So site logistics, a lot of what a superintendent is responsible for is to make sure that all the material coming on site is organized, and that's where the cranes are sitting, where the pumps are sitting, and storage is thought through so that you're not too blocking yourself and creating more of a hazard than is thought through so that you're not too blocking yourself and creating more of a hazard than you should have. So this is a representation of some of the work we did here at the White River Bridge. It's kind of an odd screen share, but we did work through the model to determine which direction the structural steel beams were going to arrive on site, where one crane would receive it. We had a lot of tandem picks with cranes. So in general, pre-stressed beam, girder erection, or big steel beam erecting, using the site logistics tool in the BIM model has helped me on multiple projects to make sure that we didn't create more of a problem than we solved during the process. So this, relatively speaking, this is a relatively easy thing to do, and you can get a medium reward. Because kind of in general, where BIM really helps you is it solves problems digitally before it becomes a real problem in the field. The analogy I like to use is it's hard to appreciate the bus you never got hit by. Meaning, okay, let's say, for example, site logistically, we didn't think the plan all the way through. We stored a bunch of materials, and then when it came in one location, and when it came to set pre-stressed beams or steel beams, our crane was out of radius. So then we're scrambling to move a bunch of things, or potentially we'd even put an excavation where we shouldn't have, so that it becomes a huge problem. So by building the project digitally, you're solving problems. We use this because I had some young guys, quite frankly, who were darn good at building BIM models, and then I had a group of older guys with gray hair and AARP cards that weren't really super interested in this new BIM thing, but they liked being able to see the sections that the model would generate. So one team would be generating the model three-dimensionally and hand it off to the team that never got out of 2D, but that would help them with the shoring stack, which is pretty critical. You don't want to have a 5-foot frame when only a 4-foot will work, or vice versa. So our team did the engineering support for multiple 50-story high-rises in Miami, 832-foot panorama tower, and a whole bunch of little small buildings. And we did definitely in Miami, 832-foot panorama tower, and a whole bunch of little small buildings. And we definitely gained efficiency by by the 2D and 3D guys working together. The survey points. Now we've crossed over into the area realm from when you can use a one-time bid model to now you have to maintain the model. So once you're committed to doing the survey from the model, your difficulty went from low to medium, so you have medium effort, medium difficulty. But the challenge, as many of you would probably already know, is the Z direction for your surveyors is the hardest dimension to pull. So once you have a model, and once that's a coordinated model, I guess one good example would be the all aboard Florida rail station, over 3,000 embeds in the concrete structure. So the survey chief was getting the models from the structural steel contractor, and they were updating to his model, which he pulled his data points from on a daily basis, and then they went out, used those data points to locate the embeds in the field, and then they turned around and laser scanned it and basically did an as-built, validating that what happened in the field was accurate. So change orders from the model, again, you're maintaining the model, and if you're doing the work, you might as well get paid for it. So as you continue to update that model, you can pretty easily find the variance from, there's another software package that is really good at comparing model to model. It'll generate, ads of square foot of surface area, really any quantifiable measure. So you still need the estimator's skill set. So for example, if the engineer optimized the structure and instead of just having 24 by 24 columns and 36 by 36 columns, he introduced 3 more sizes in between those, yeah, that's a net reduction in quantity, which you probably made the concrete contractor's job more difficult because now you have different formwork, limited, less uses. So you still need that estimator or the project manager to say, hey, there's more to it, there's productivity component, but you're probably not arguing about quantities. So change orders from the model, that's medium level difficulty, potentially a really high reward because there's really no argument about whether there's an increase or decrease in quantities, and a medium level of effort. Coordination with other trades. So this is, as a general contractor, where you're probably most likely to see a federated model or multiple models coming together in one space. The concrete contractor's contribution would be the concrete model, but within that, there would be duct work, fire suppression, all the gravity lines, anything that has high probability of conflict, especially on the MEP side. Outside of the mechanical room, you probably got to fit all the stuff in the ceiling. There'll be conflicts with structure. So, again, the intent is to resolve all the problems with the conflict in the digitally, virtually, before you do it in the field. This is where most general contractors will justify the whole BIM operation. So line drawings or lift drawings, depending on who you talk to, can certainly be generated from the model. This is an example of one on a project. The information provided is enough so that the carpentry crew can go out and build from that one drawing. So we're integrating multiple sources of information, and it takes some effort to get to this point to resolve, for example, this complex slope in a slab in areas where there may be no slope at all, or a pretty serious slope, 11% grade. So this is very difficult to do two-dimensionally, but once you have a model, it's just the standard layout information, no dimensions off grid lines, dimensions to the face of the form. So lift drawings have been kind of a key element of the outcome. Laser scanning. So laser scanning, if you haven't already had this on one of your projects, it's probably coming to a project near you soon. It really is a double-edged sword. So you may be finding things where others have not done their job how they were expected to clear you of blame, or maybe implicated by the laser scans themselves. So when someone says it's asked something in and out of tolerance, that is not really a one-word answer most of the time. This is a model of an existing building, or a building under construction. There was discussion about whether the masonry was where it was supposed to be according to plan, or where the concrete walls were out of tolerance. And of course, the mason and the concrete contractor were both looking at each other like, my stuff's where it's supposed to be. So there was a scan done of the building, overlaid with the model, and this is called a heat map. What you're seeing is in blue locations, or light blue or dark blue, closer to the center of the building or away from the theoretical face, and in red, locations closer to the streets or further away in the opposite direction from where they should be in theory. And everything is green is within a half an inch of the theoretical location. So there's not really one answer. There's elements of both walls and concrete walls and masonry walls that are in and out of what could be the tolerance window. And for all intents and purposes, if you're looking at this building, you really wouldn't know the difference. It's just, you might see the variation, but when you introduce a scanner, you're finding millions, if not billions, of data points. It was about $30,000 worth of gear that went into the ability to do that one time. Okay, so now you have a model. So I should have mentioned that the level of difficulty is pretty high, the level of effort's pretty high on laser scanning, and the reward depends on the feedback that you get, how close you were to tolerance. So 4D side, this is an example from the project I'm currently building. You're seeing multiple colors because there are scheduled activities for form, reinforce, place, cure, strip, and then some of the elements have multiple pours. This is actually a lot of mass concrete elements. So we're kind of zipping through time. I don't know if you caught that there's a timeliner running in the upper left-hand corner. That's just one example of a schedule linked to that was a portion of the schedule. Now you can compare the baseline schedule to an update, and that's an example here. So what was happening was that this element, this helical parking garage ramp, was not complete, as this is the baseline at the bottom says it would be, but the concrete comes far ahead of what the baseline schedule said it would be. And the tower was on level 9, the baseline said it would be on level 8. So the discussion about needing to work overtime in order to catch up to the schedule because one element of work was not done was a short conversation. When you looked at the overall picture, that was even for a novice of knowledge of this project to understand, that clearly this progressed actual project schedule on the top half compared to the baseline on the bottom half, contractor was ahead of schedule. So that kind of ended the discussion about having to work overtime or adding more people to get an element of the work on time. Critical path was fine. That can be really done comparing any two schedules to each other. So another application of that type of use of comparing original plan schedule versus actual. This was a project that had multiple coordination RFIs Ironically, they said they didn't have the money to spend on BIM or do coordination. They just found all the problems during construction. So everything you see issue here was impacting some part of the work that needed a design solution, and then that design solution had to be taken to the building department and passed through their hands so that when the building inspector came on site, that he could see the approved solution, if you're keeping track. But this actual schedule with delays is not keeping up with the original plan, schedule. So, back to the question of how do you quantify savings with BIM, that team would have had a much better chance of meeting this original plan schedule if they had found all these design validation issues prior to have crews and formwork and cranes and all the associated forklifts and other equipment sitting there at the face of the work, trying to go to work. Then they find an issue, and now we're scrambling to find them something modestly productive to do instead of laying these guys off. So any project that has multiple months of delay is likely to run way over budget, even if we get clarified. If when it comes to claims, there's definitely some level of difficulty associated with being able to generate a product like this, but you got a really high potential for reward because you're able to get someone who doesn't know much about this project up to speed very quickly. And I mean, probably nobody on this call has had anything to do with this building or ever will, but you can just see in the side-by-side comparison within a few minutes that clearly the actual schedule with delays was extremely impacted. It was death by 1,000 cuts. It wasn't like one major issue. There were just issues all over the place. And the cumulative effect of that was the overall project coming in way later than expected. So this is one of those, overall project coming in way later than expected. So this is one of those, if you're in a big dispute, the potential for a much higher recovery when you can have a story associated with a visual picture instead of handing someone a bar chart schedule and a stack of RFIs and said, this was my problem. That doesn't tell a very good story. So this tells a much better story. Another application of using the 4D would be to go try and take this to the foreman. Why the foreman? In my past 20 plus years, over 80% conservatively, probably over 90% most of the time my workforce was Hispanic, and a lot of English as a second language. So they're excellent workers. Communication is a challenge, and if you can give them a tool, I mean, we're counting on guys to potentially being able to read drawings. We wouldn't even try to give bar chart schedules. We're giving them goals on a weekly basis, and it's much easier to watch a little video about what that goal is, what does good look like, than it is to explain, I need you to get 8 square foot per man hour on those columns. On the shear walls, you got to get 14 square foot per man hour. And when we're placing concrete, we've got 1 man hour per cubic yard in the budget. If you show a guy a video, I think you have a much better opportunity to communicate the plans. But that could be challenging because the master schedule typically has a weekly short-term schedule. So another application that's one of the software packages has more recently integrated into their system is a safety review. Because hazards change versus time, you will potentially look at the life cycle of a project and review different hazards that present themselves over the course of that project. So maybe you have an overhead hazard that you determine, okay, we got a steel structure. Until we have a metal deck on that floor, anyone's excluded from going in underneath it. Maybe you create within the schedule a safety buffer or a safety zone, a safety exclusion zone, or maybe you have a safety exclusion zone, or maybe you have a fall protection area that's designated as it moves through the project. Really, there's electrical hazards, really any potential hazard, swing radius to a crane. If you can model it, you can put it in the schedule. And these are the type of things when you're looking at the permanent works or a bar chart schedule that are extremely difficult to plan for unless you're looking at a model and that versus time. So this is one of the newest applications. Parsons is developing a series of videos to try to educate workers about schedule versus time hazards. So now we're starting to talk about 5D. This is not an early in your BIM journey type of thing you want to try. The linking of the model to cost is 5D. So, okay, what am I going to do with that? Well, any specific elements of the work can have an attribute attached to it. So the information associated with the model, the building information model, you could have a manpower budget for, say, this column or this beam or this deck, whichever element that you want to attach an attribute to. It'll certainly have its own native attributes, like this is how big it is, this is how many cubic yards it is, but you can add any dollar associated item that's discrete, like manpower, and then you can have the cumulative effect of the schedule. So basically, overall, I know guys who have effectively done this with labor only, because the challenge if you're trying to do the entire job in BIM is there's a lot of elements that cost money that aren't necessarily modeled. So the cranes, really any associated equipment, forklifts, the supervision, your trailers, all of those things are buckets of general conditions money that don't really have an element to keep track of. Now, labor will be your biggest variable cost, and the thing that is going to make you or break you as a concrete contractor. You're probably not going to screw up the concrete quantity by 30%, but you can certainly mess up the labor quantity by 30%. So I guess the 30%. So I guess the takeaway is once you're pretty well established into BIM or VDC, and this is one of those things that you want to tack on, it'll take an effort to go from estimating all the way through the life cycle, because there's also, you have to estimate it the same way that you model it. I'm going to give you my contact information at the end of, this is an area for improvement. So the formwork model is completely independent of the concrete model. Probably actually built by a different person. Maybe your internal guy, maybe your formwork vendor. I will say that in general, the Europeans are pretty far ahead of their American counterparts when it comes to VDC in the formwork world. I mean, I love EFCO, but they're not going to give you their pieces in parts. As far as if you want to use technical structures or Revit to model your job. So, okay, what are we talking about? Let me just skip ahead a little bit here. So, you can see on the screen, this was generated by Miva. This is basically a live screenshot of one of their detailers putting together the form workshop drawings for a job. Now, this is obviously someone who's had a lot of practice doing this, and if you're gonna, either they'll have to create a concrete model or you have to create a concrete model for all your bulkheads. But basically, what you'll end up with is an extremely detailed breakdown of how much formwork you're going to need, and then you can, have an interactive discussion about utilization, how these go together. Everything's three-dimensionally easier to represent when you give someone a three-dimensional drawing like this of what that element looks like, as opposed to a CAD drawing that's giving you one elevation and another elevation. The corners are difficult to understand, inside corners, outside corners, how that works together, and that T shape would be difficult to understand. I mean, it's, I guess, just an example of if you want to start modeling your formwork, the pieces and parts have been made by Perry, Riva, and Doka, and they're commercially accessible. Some of the American counterparts, you're pretty much going to have to make your own pieces. So, how much level of effort does it take to do shop drawings? It depends. There's not one answer. It depends on which system you're using. So the difficulty will be anywhere from low to high. The effort can be moderate to extremely high, and I would say, regardless of whether you got to do it yourself or they'll help you, there should be a pretty good reward from that. So best practice, what do I mean by that? So most every contractor is going to have, or even at the superintendent level, certain formwork systems that's their bread and butter system, that they're a go-to. If I'm building the deck, I want to use this system. Well, maybe it's high-load shoring. And a best practice would be you making a series of small, it could be 3-minute, 5-minute videos that basically highlight the safest way to do it, the most productive way to do it, things to sequentially to watch out for, and how to strip it. The things that you want that seasoned veteran to be able to instill the years of experience to teach the new guys on the team, or even the moderately productive guys on the team, the foreman who's, he's good, but he's not great. Maybe you're putting us at risk because you're not using this center tripods. It's a safety issue. Or the missing clips. I really, the possibilities around this of where you could go, because everyone has their own system that they're the most comfortable with. But really just looking at capturing that baby boomers experience in a short video is really the goal that I'm talking about here, to hand off to your millennials, because they love watching movies. So 40 cycling of formwork. Okay, now you have a set of drawings, and how are you going to move that formwork throughout the building? Basically attaching the formwork to the schedule. That's really what's trying to be addressed here. It can be pretty challenging because there is a lot of the pieces and parts that go into a lot of formwork systems. So you have the potential for optimizing the amount of formwork on the job, the potential to be confident that you can start returning things because you don't need it anymore, because okay, if at this point I'm at my peak total formwork quantity, and what I need to complete is well defined. So that's where you're getting into just that little bit of got too much delivered early, hanging on to stuff for too long, taking that, how big of a cushion the job site has, reducing that down a little bit because you're confident that you're not going to come to that last pour and run out of wall panels or post doors. That's related to the next item we're going to look at, which is if you really got your stuff together, you could potentially do your entire multiple project inventory modeled versus time. But I have to admit, that was a pretty far cry from what I was able to do tracking form work with my former employer. We were just happy that we didn't lose too much of it at the end of the year. So you're talking RFID to track all this stuff across the fleet. There's some challenges there. Okay, so the rebar model itself. This isn't going to be the best rebar overview because there's people who are much better in this detail. Use it in limited locations. Part of the challenge is from multiple discussions that I've had with multiple fabricators and detailers, only somewhere between 4 and 8 or 9% of the detailers in the U.S. today have the ability to model in 3D. So you wiped out 90% of your potential detailers if you wanted virtually detail the entire project. Even the guys who do this all the time don't necessarily detail every bar in the model. You can, and I would call that ideal, but just so you're aware, let's say you got a brand new BIM job and the general contractor hands you the spec. If it says you have LOD 400, which it probably does, at least 350, then you have just bought providing a rebar model, unless you have specifically excluded that. If you have an LOD 300, 350, 400 concrete model, that includes the rebar down to potentially the chairs. I mean, it's what the most value is often found if you're not going to detail the whole job in resolving congestion. Connections at shear walls meeting columns, beams meeting columns, any major interface of a structural support system to another embedded items, structural steel meaning that there's a high probability you're going to have some conflict, and items, structural steel meaning that there's a high probability you're going to have some conflict, and just modeling those elements to resolve congestion is probably worth the effort all by itself. Canal Bar, Florida, multiple pours were interrupted by having congestion, and it could have been caught beforehand, such as what this potential blockout was doing to the horizontal reinforcing the beam. But it was resolved in the model. So fabrication for the model is the ideal. Now, this is actually a snip from Tekla Structures. ASA has the platform that can do 3D modeling in general. Find out from your fabricator, but if you're a great customer, maybe they might do it for free. So let's say, sounds great, Mike. I'm convinced. Let's do some BIM. Let's do some VDC. Well, before you jump into the deep end of the pool, I would suggest humbly that the best place to start would be to prototype some elements of all the things that I just showed you on a couple projects, and then if you like it, great, scale it up. If you figure out, maybe a layout was not our thing, but we're definitely going to do 4D baseline schedules and update them in there. Great. So just, how to save some money by potentially only doing some elements and then taking those to a bigger level. If you're going to do it, I'm going to find some people who are interested. If this is just the big boss came in and said, hey, we're doing BIM today, it might be a challenge. But if you find some motivated individuals, then you make them your champions for endorsing this. I'm going to guess it's your younger guys. You're telling this is an opportunity for them to gain advancement. There'll probably be some enthusiastic volunteers, I hope, for you. And no matter what, again, I would suggest that this, in Britain, they have mandated BIM on all government projects. This was developed there to talk about. This is really for any change in general, any kind of change. If you have vision, skill, some incentive, do the right resources, have a good plan, you're going to have a good change initiative. If you leave out the incentive piece, I feel like people will turn to say, I've been doing it the same way for a long time. If there's no downside for me not doing this, other than the boss makes more money, whatever. I mean, it's just, you really gotta, if you're pushing something challenging, I feel like the best way to be effective at the end of the day is to give the guys at the face of the work who are actually integrating the technology some incentive in the program. So that's pretty much the high-level overview of my presentation. And if we're ready to, Eric, open the floor to questions.
Thank you. We will now begin the question and answer session. If you have a question, please press star, then 1 on your touch-tone phone. If you wish to be removed from the queue, please press the pound sign or the hash key. There will be a delay before the first question is announced. If you're using a speakerphone, you may need to pick up the handset first before pressing the numbers. Once again, if you have a question, please press star, then 1 on your touch-tone phone. And standing by for questions. I'm showing no audio questions at this time.
Okay, so if you come up with a question and want to bounce something off me, I do know which software was behind all of those slides that you saw, and it's not a secret. I'd be happy to share it. This is my mobile number and my email. If you have anything that you think of in the future, drop me an email and see if I can help you out.
Thank you, ladies and gentlemen. This concludes today's conference. Thank you for participating. You may now disconnect. Speakers, please stand by for your post-conference.